Newton's laws of physics, P2 represent forces as vectors. Now these vectors, these forces, we're gonna be showing them as arrows. Because an arrow has a point where it starts and it has an origin, has a direction, and it has a certain length. Now the point of origin will show where the force is starting at. The length of the arrow will show us the magnitude, the amount, how big that force is, and in the situation of forces, and because this can be also velocity and acceleration, but we'll stick to forces for the moment. So the length of the arrow shows us how big that force is, and then the tip of the arrow shows us the direction of that specific force. So these vectors are shown as arrows. If we're looking at this airplane, now we see that this airplane it has four forces acting on it. There is the lift, that's the force that's going to help the airplane go upwards. There is the thrust from the engines, the force that's going to help the airplane move forward. There is the weight of the gravitational pull from the earth, the force that's trying to pull the airplane down. And there is the drag, which is the air friction, the air resistance, the force that is there because this airplane is moving through the air, so that means the air is creating some friction. Now if we look here in the top corner, we see that the lift, it has exactly the same value as the weight. We're always going to analyze these forces as comparing up with down, left with right. So I'm just gonna write here, so up, compare up with down, and left with right. So we're always going to compare up with down and left with right. Now if we compare up and down, we see that the lift equals the weight, but we see that the thrust is larger than drag. That means this object, we have up and down balance forces, but the force that's pushing the airplane, pushing or pulling the airplane forward is bigger than the drag. That means this airplane must be accelerating, must be going faster. The same thing here. Let's remember the length of the arrow means the amount, the magnitude, the value, how big the force is, and then the tip of the arrow is the direction, and the start of the arrow is the origin, where the force is starting from. Now, as this person is running, there is the body weight that's pulling the person down. That's the pull from the earth. There is a ground reaction force. Remember, we discussed about earlier, we also call this normal force. There is friction, because friction actually allows this specific person to move forward. If there was no friction, this person would not move. And there is also air resistance. There is air resistance because the person is running through the air. That means the air creates a drag. That means the air is creating a resistance. Next would be an object that's sitting on a surface. Again, here, as we can see, we have a force, which is the reaction force from the surface, which is called normal force going upwards, exactly the same value as the one for the force going downwards, which is the gravity. And then we have the friction to the left, and this is smaller in size than the force that's pushing the object, the applied force that's moving the object to the right. So this object will be actually accelerating to the right, will be moving faster to the right, because the blue arrow is larger than the red arrow. The green and the dark arrow, the black arrows, they are exactly the same. So in those situations, normal and gravity they are balanced. A book that's standing on a table, there is the weight from the book, and there is the normal force, the reaction from the table. Now, if we look at the size of the arrows, we see that these two arrows are exactly the same size. So the normal force, the reaction from the surface, is equal with the weight, the gravitational pull from the earth. That means in this situation, this book is not going anywhere. is just sitting there because these two forces are balanced.